Welcome to AP Podcast 8.4. This is on ions. We're going to talk about the size of the ions, their trends, and so on. So again, this is review stuff. So this is stuff we know. Atoms tend to react to form noble gases, and so that means metals are losing electrons and nonmetals are gaining electrons. So if I was just going to scratch out a periodic table, and you guys know how I draw, so just kind of bear with me. Okay, there's a Richardson periodic table, and right around here we've got the that transition section. So over here are our metals, right? And those are the ones that are going to be losing electrons. Where over here, these ones are the nonmetals, and they're going to be gaining electrons. And that's just, again, stuff we know. So if we look about the size of the ion, as you go down the period, down the table, hopefully it makes sense to you that as you go down, the size is going to increase. And that makes sense because we're adding energy levels of electrons, right? And so it's getting bigger as you go down. Another thing to think about is cations are smaller than the atoms they come from. And that should hopefully make sense because a cation has lost an electron. So if I've got an atom here, and here's some levels. Wow, that's horrible. Let me just redraw that. If I've got an atom there, and here's a couple energy levels, a little bit better, and this thing loses an electron. In other words, an electron goes away, and now this outside energy level is gone, right? Maybe it was a sodium atom or something. Look what happened to the size of the ion, okay? So there you go. It gets smaller. So hopefully that makes sense. Conversely, if I am an anion, I've gained an electron, and most likely what's happened is that maybe you had 7 electrons here, and we added one electron, so now we have 8 electrons. Well, what's going to happen to all the electrons in that set of orbitals? They're going to repel, causing that cloud to be a little bit bigger. Okay, so that probably makes sense to you. As you add things, the cloud gets bigger. As you subtract things, the cloud gets smaller. Now, as far as what's going on with the size of these atoms, though, as you go across, they get smaller because they're losing electrons, right? While their nuclear charge is increasing. And then all of a sudden they get larger. And that should make sense to you because here we're losing electrons, and then we get to that point right here in the transition section where we start gaining electrons, so then they're going to grow. So it's not like you could just say, the trend is as you go across it increases or decreases, because with the ionic size it does both. You just have to be aware of where that transition starts occurring. All right, so here's kind of a picture of what I'm talking about. This is row 2, right? We've got lithium, beryllium, boron, carbon, and you can see they're getting smaller, right? They're losing electrons. At the same time, the nuclear charge is going up. So it's causing them to really shrink. Then we get to nitrogen, and nitrogen, look at nitrogen. It's going to gain 3 electrons, so it's going to grow. Oxygen is gaining 2, fluorine is gaining 1. So the trend is it gets smaller, and then when you get to that stair step, along the periodic table, it starts to increase. All right. So hopefully that makes sense. All right, I got a new term for you. Isoelectronic. Ooh. Okay. There you go, isoelectronic. Now, iso just means the same. So what we're talking about is ions that have the same number of electrons. And here's a number of them right here. So look at aluminum. Aluminum with a +3 charge. Well, if you were to look on the periodic table, aluminum has 13 electrons. If it's got a +3 charge, it has lost 3 electrons. So now it has 10 electrons. Magnesium has 12. It's lost 2, sodium 1, and so on. You can see how this works. So all of these have 10 electrons. All right? However, even though they have 10 electrons, what has happened to the number of protons? All right? Well, I'm just going to write the number of protons here. So aluminum has 13 protons, magnesium has 12, sodium has 11, neon is 10, fluorine 9, oxygen 8, and nitrogen 7. Okay, so what we've had happen here is with aluminum, we've got 13 positive charges, right? But only 10 negative charges. So it really causes that atom to shrink. or I should say that ion to shrink. Magnesium has 12 positive charges, only 10 electrons. It's a little bit smaller, not as much positive charge or effective nuclear charge to call it to shrink. Here's sodium with its 11, all right? And then here's neon with its 10, and then you can see fluorine, oxygen, and nitrogen. So what's happening here is we're increasing, or the nuclear charge right here is pretty big, 13 protons, and but only 10 electrons. And then when we start getting here, now we're adding electrons, but at the same time, the effective nuclear charge is going down. So there you go. So that's what happens when you have an isoelectronic ion. You got to think about both the positive charges and then the negative charges. All right. So let's look at a practice problem and see if you can't figure this out. What noble gas has the same electron configuration as each of the ions in the following compounds? All right. Now to do this, you need a periodic table. So if you were to look at cesium on the periodic table, you would see that it's element 55. All right, 55. Oop, I don't want blue. Blue doesn't work very well. It's 55. And what noble gas is close to 55? Well, what's cesium? Cesium is an alkali metal, right? So it's going to lose an electron. So it's going to lose an electron and have the same noble gas configuration as xenon. Sulfur has 16 electrons, and it's going to gain 2 electrons. And then it'll have the same electron configuration as argon. So without me doing it, what would be the answer for strontium and fluoride? Well, for strontium, if you said krypton, you did well. And for fluoride, if you said neon, you did well. So there you go. Now, pause the video for a second and give 3 ions that are isoelectronic with krypton. Okay, well, krypton has a total of 36 electrons. Now, what you can do on the periodic table, let's just imagine here's one column, and here's krypton right here. All right, Kr. Oh, that's horrible. Well, let me write it over here. It's Kr, right? Now, imagine you could pick a couple ions right here, or a couple ions over here. So, for example, some of you might have said bromide or selenide, or you might have said rubidium, Rb plus, or strontium. Okay, so there you go. So hopefully that's making a little bit of sense. Just playing with these ions. Let's look at one more thing. Here we have a group of vanadium ions, and we want to put them in their order of an increasing size. So we're going to put the smallest ion first and then the biggest. So take a moment and do that. All right, well, hopefully you realize that vanadium is a metal, and notice that it's gaining a positive charge. What does that mean to us? That means to us it has lost electrons, right? However, the number of protons has stayed the same. So if you want to go from smallest to biggest, you really just have to go this way. All right. What about these guys? Now these are alkali metals, and they're going down a group. And what happens to the ion size from smallest to biggest? Yeah, so it goes this way. So there you go. All right, so there's just a quick introduction or review on ions, including the trends and their size and what isoelectronic is. And we'll talk about it later if you need more help. Hope this all went okay. See you next time.